Hello everyone. So today I am going to discuss two different types of synchronous counters. One is the ring counter and other one is the Johnson counter. I have drawn a comparison between the two for a better understanding. Now, if we see the ring counter, since it's a synchronous counter, the clock is given to each and every flip-flop at the same time. Plus, you can see there is a preset button here. So, according to the preset button, the counter will start. So, we can see from Q2, initially it has been passed to D0, and based on the values of D0, you can get new values of Q0 and it will keep on shift. For the ring counter, the modulus number is n. Here n is nothing but the number of bits, and the maximum count up to which it will count is 2 to the power of n minus 1. For example, if the value of n is 2, if it is a 2-bit counter, the maximum count will be 2 to the power of 2 minus 1, which is 2 to the power of 1, which is 2. So the possible states will be 0, 1 and 0, 0. There is a new thing here, which is the frequency at the output. That will be equal to the frequency of the clock divided by the mod. Mod here is n. So f clock by n. So this is about ring counter. Now let's see about Johnson counter. Here again, since I mentioned it's a synchronous counter, clock is given to the flip-flops at the same time. And here we see the value of Q2 bar is passed to D0, and based on which the values are changed. For example, if my initial value is 0, 0, 0, my next value will be Q2 bar, which is 1. So, and that will get shifted towards the right side. So it will now become 1, 0, 0. Same way, again Q2 bar will be 1 and it will be shifted. So it will be 1, 1, 0 and so on. Now for Johnson counter, the mod value is 2n. Again here n is the number of bytes. So for example, if it's a 3-bit counter, the maximum value will be 2 into 3, which is 6. For mod, that is 6 possible states will be the modulus number, and maximum count will be 2 to the power of n minus 1. So if it's a 3-bit counter, so 2 to the power of 3, 8 minus 1, 7. So as here we can see, if I complement 0, it will become 1, 1, 1, which is, 1, 1, 1, which is 7. So this is the maximum value. And f will be f clock by 2n. 2n is nothing but again the modulus value. So I hope the concept of ring and Johnson counter is clear. Just remember one small thing, that in Johnson counter it is Q2 bar which is getting passed. And one more important difference is that ring counter is not a self-starting counter. We have to give a value to preset bar to make it start. Whereas Johnson counter is a self-starting counter and it is based on the value of Q2 bar which gets shifted. So this is a very important difference. And based on the performance, Johnson counter is better since the modulus number is higher, which means more number of states. Let us see some gate questions based on this. We will start with the question of ring counter. The clock frequency of a 3-bit ring counter is 12 kHz. Find the frequency of the counter at the output. As we saw, the output frequency is nothing but clock frequency by modulus number. And we know the modulus number for a ring counter is n, which is the number of bits. So since it's a 3-bit counter, n will be 3. So F out will be F clock by 3, which is 12 by 3, 4 kHz. Next question is based on Johnson counter. This is a bit different. They are asking us to find the number of unused states for a 4-bit Johnson counter. Now the formula for finding number of unused states is 2 power n minus the modulus number. Now modulus number for a n-bit Johnson counter is 2n. So in this case it will be 2 into 4, 8. So the number of unused states now will be 2 to the power of 4 minus 8, which is 16 minus 8 equal to 8. So I hope these two counters are clear. Tomorrow I will discuss some typical examples on counters and we will end the chapter with that. Thank you. Please feel free to comment below.